Okay, in this tutorial we're looking at differentiation of exponential functions. So it's a nice a short section, this one. Okay, so if our function f of x equals e to the x squared, then our derivative also equals e to the x squared. So derivatives of exponentials are really quite good. So e to the x, okay, becomes e to the x for our derivative. If we have f of x equals e to the kx, then our derivative is k e to the kx. So k is just a constant. Okay, so if you like, k is an element of all real numbers. Okay, so our constant just comes down the front. If we have some function f of x equals e to the power g of x, okay, then the derivative is g dash of x e to the gx, sorry. So if we have some function as our power, we take the derivative of that function, bring it out the front, okay, and then leave the rest the same. Okay, so we'll have a look at some worked examples. So we have differentiate the following. We have y equals e to the negative a half x. So that's this case here. Okay, where we just have a constant. So we can say simply dy dx equals negative a half e to the negative a half x. And that's it. Don't need to do anything else for that one. Okay, if we're having a look at this one here, okay, then we're going to say dy dx. So we've got y equals a quarter e to the 2x plus e to the x squared. Okay, so again, this is like our kx1, so our 2 comes down the front. Well, 2 times a quarter gives us a half e to the 2x. Okay, and then we also have this part here. Now this is a case where it's e to the gx, so we're going x squared. So we take the derivative of what's up the top, so the derivative of x squared is 2x. Okay, and then make it e to the x squared again. And that's all we're going to do for that one. This one here, okay, a little bit more complicated because we've got y equals e to the x, take 2 all squared. So what we need to do for this one is say that we've got, well, e to the x take 2 times e to the x take 2, okay, which means that we get y equals e to the x times e to the x. So we've got the same basis, so we can add our powers, so we'll make it e to the 2x, take 2e to the x, take 2e to the x plus 4. So that means we get y equals e to the 2x, take 4e to the x plus 4. Okay, and so we can take the derivative now, so dy dx. Okay, again we've got a constant, so that can come down the front to make it 2e to the 2x. Take away, well, e to the x stays the same, so 4e to the x stays the same, so we get take 4e to the x. So here, if we have just a constant out the front as well, so we could say we've got f of x equals a e to the x, then f dash of x will equal a e to the x as well. A constant out the front won't make any difference at all. So that's actually all there is to this section. It's not a very long section, and it's quite nice with the way our rules work for that one.